All right, welcome back. So, again, I want to thank the previous group with Usman and Michael. They did a really nice job of setting the table for this. So today we've got a great couple of speakers here. Mike Raposa is the principal consultant in M&E at AWS. Brenton Miller is the SVP of Discovery Communications, as is Dave Duvall. And they're going to talk a little bit about Discovery Channel's broadcast workflows and channel origination in AWS, which is, again, one of these cutting-edge highlights that we're really lucky to be able to talk about here at conference. So with that, I'm going to turn it over to Michael.
Thank you, Ian. So let's just dive straight into what we need to talk about today. We have a lot of great content to cover and a short amount of time to do it in. So I'm going to give a quick overview of media and entertainment on AWS. It's going to be very brief. Then I'm going to talk about the team that I work for, which is the professional services team. Then we're going to dig into the good stuff. So we're going to talk about broadcast on AWS. I'm going to go into depth and detail about the challenges that we face doing broadcast on our platform. And then I'm going to hand off the mic to Dave Duvall, who's going to talk about AWS adoption. And then Brenton Miller is going to talk about ingest and broadcast playout. So you may have seen this slide previously at Usman and Michael's presentation. It's all of the media workloads that are currently running on AWS. And this talk is primarily about the upper right-hand corner, where we're going to be talking about playout and distribution. So what is broadcast playout? So it's a little different than what we were talking about with that first presentation given by the Elemental team. We're talking about the transmission of content, typically over satellite. So that's the broadcast piece. And then from the broadcaster down to the affiliate. So broadcasters, we're talking about Turner, we're talking about Discovery Communications, talking about Fox. And affiliates, we're typically talking about, at least here in the US, cable companies. So it would be Comcast, Time Warner, Cablevision, et cetera. And that broadcast playout stream is going over their cable plant through your neighborhood to the set-top box where you're actually viewing it on your TV. And the key takeaway here is, for most broadcasters, this is the largest generator of company content, company revenue. So most of the money that they make is either from affiliate deals that they cut with Comcast, Time Warner, et cetera, to air their content, or the advertisement that comes down from or is advertised in that broadcast playout stream. So it's a huge aspect of the revenue generation for the company. And for most broadcasters, the OTT, or the over-the-top delivery for internet-based distribution, is actually just a small portion of the overall revenue of the company. Broadcast playout is a much bigger piece. So let's talk a little bit about professional services, the team that I work for. So the professional services team is a team of consultants that help Fortune 500 companies migrate workloads to AWS. We're a team of technical specialists. We provide advisory services. We collaborate with your partners, premier partners like Cognizant, Accenture, Second Watch, CloudReach, and we have a proven process for success. So we do a lot of engagements. Let's say you're, I don't know, you have 10,000 workstations or 10,000 servers. You'd like to move them to the cloud. We have a process that walks you through making that migration happen. I happen to be working on a project right now where we're taking a 2 million line monolithic banking application, splitting it up into microservices, and migrating that to AWS. That's sort of the projects that the professional services teams work on. And we focus on all aspects of cloud adoption. So whether it's operational integration, so integrating with your change management database, or how you're doing backups, or if it's IT transformation and how you change your business to leverage the cloud, security compliance, application optimization. These are all things that the professional services team can help you with your migration. So let's talk a little bit about broadcast on AWS. There we go. So first off, I feel like it's important that I give you sort of an overview of what broadcast on AWS looks like. This sort of frames the conversation of what you're going to see in the next few slides, and also frames the conversation that Brinton is going to go into to talk about broadcast in depth. So we start with AWS. That's the most obvious piece. And on AWS, we have some generic storage. I'll dig into a little bit more what that generic storage is. And on that generic storage, we have some pre-rendered content. So we have a video of a post-production piece of content that could be something like Deadliest Catch or Naked and Afraid, so some TV show that Discovery is airing. Along with that, we have some graphics and some overlays. So a graphic is like that little Discovery logo that you may see in the lower right-hand corner of the broadcast, or a pop-up that says, next on Discovery in the next 5 minutes, Naked and Afraid. And then we also have ads for the commercial breaks. We may have closed captioning information included with that. That's all sitting on our storage array. And then we have a scheduling piece. So this is a bunch of applications, or it's a bunch of instances run by a person who is scheduling up these assets for playout. So he's saying, OK, at 9 p.m. Eastern, Deadliest Catch is going to air. It's going to have these graphics. It's going to have these overlays. The graphic is going to run the entire length of the show. This overlay is going to show at 9:55. This advertisement is going to hit at this particular frame and at this particular time. And then we have some GPU instances. Those instances are actually going to do the broadcast playout. So the scheduler injects that schedule into the playout machines, basically telling those playout machines, this is what you need to do in order to make the playout happen. The GPU machines are downloading that content from the storage array, and then they're live assembling the content. So they're basically taking that pre-rendered TV show, they're injecting all the ads, they're injecting the graphical overlay, and they're making the output stream. So the 50 megabit MPEG transport stream, HD, at 50 megabits per second is being transmitted down over Direct Connect back to Discovery's on-premise data centers, where it grabs the satellite uplink, gets up to the satellite, and then is finally downloaded to all of the affiliates for the end users to actually view the content. This is what we view as broadcast channel origination on AWS. So what are some of the challenges with this design? So we have a couple. So first is live transcoding. We're live assembling that content and live transcoding that content on the fly. It needs to be perfect. There can't be any gaps. There can't be any slowdown. If we have any gaps or slowdown, we'll go off air. And going off air is really bad. We need 5 nines of availability, right? So we talked about this being the largest generator of company revenue. So we need the highest level of uptime. So we're talking about multiple availability zones and multiple regions. I'll stop there for a second and also mention that these 5 nines, when you go to the cloud, are flexible. So you don't always have to have every channel at 5 nines. You could have a channel that's not generating a lot of revenue at a lower level of nines. You can also think of the 5 nines as dynamic throughout time. So you can have a channel that is a high revenue producer that needs 5 nines during the evening hours and prime time, but you reduce those number of nines by shutting down equipment or shutting down instances in a region or in a high availability zone, and reduce down to 3 nines during the evening hours, late evening, and early morning. We're dealing with a migration trifecta. So we're doing 3 migrations at once to migrate broadcasts to AWS. So we're migrating from hardware-based solutions to software, bare metal to hypervisor, and from on-premise to cloud. 3 migrations going on at the same time. Definitely a challenging project. We're operating at massive scale. So Discovery has over 400 channels in over 200 countries worldwide and is in hundreds of millions of households. That's massive scale and a global reach. We need the TCO to work, right? The total cost of ownership needs to make sense. If we're going to migrate to the cloud, it doesn't make sense if it's going to be more expensive. So we need to leverage technology and services on AWS that are most cost-effective to do broadcast origination. And then finally, what I felt was the most difficult technical aspect is we have a fixed bitrate output. When you do OTT, or over-the-top delivery over the internet, you can use ABR, which is adapted bitrate. You can change your bitrate based on congestion and drop down to a lower bitrate if necessary, but still get play out. In broadcast, that doesn't exist. It needs to be a fixed 50 megabits per second output always. And if you get any sort of congestion, you start to drop frames. You drop frames, you go off air, and when you go off air, you get the call from the CEO saying, we're the largest generator of company revenue. What have you done to us? So let's start with some of the challenges. The first up was, which happens with a lot of media and entertainment companies, the video assets are stored on NFS storage, typically an Isilon storage array from EMC. We want to minimize the changes to AWS, so we want to leverage a solution that's NFS-based. So we started and looked at EFS in preview mode, and we did some performance testing. The testing was excellent. We got 9 gigabytes per second of throughput with 375 clients, more than enough throughput to do the broadcast channel and origination. But Discovery came back and said, EFS is great. You're replicating to 3 availability zones. That's fantastic. But we're layering additional redundancy on top of that. And EFS isn't going to be cost-effective for us because we're basically doubling up on redundancy. We're being redundant at the channel layer, and now we're also being redundant at the storage layer, and that's too much redundancy. So we looked for another solution, a solution that we could operate in a single AZ. And the next up was Intel's Lustre file system. If you're not familiar with Lustre, it's a scale-out file system. So as you add more nodes into the Lustre cluster, it increases both the amount of storage that you have available and the throughput available within that storage array. Performance was also excellent, almost exactly on par with EFS, 9 gigabytes per second of throughput. We got 0 drop frames per 1 million. We effectively ran this for a month and never had a single drop frame. The performance was spectacular. But the downside was that Discovery was migrating to AWS specifically to get out of the business of managing data centers and managing solutions. They didn't want to manage a storage system. They wanted it all taken care of for them. So we switched out from NFS and we switched to S3. The downside here of switching to S3 is we now needed to refactor and build a new file system interface. Instead of talking NFS, we're now talking the S3 object store. We could put an overlay in front of this, like a partner like Avere, in order to emulate the NFS protocol with S3 backing it. But Discovery opted to go with native protocols, which is something that I happen to agree with. Performance was incredible, even better than EFS. Combined 40 gigabytes per second of throughput with 500 clients. And I'll pause there because we have now tested 3 different storage systems, each with about 200 terabytes each of them. If you think about what it would take to build that in your own data centers, it's effectively impossible, right? This is the innovation and experimentation that you can bring to AWS, right? This is the things that it allows you to try things, fail, and then try another thing. Stuff that you're not available, it's not available to you on-prem. And just this test alone, right? Those 500 clients, those are 500 10 gig interface clients, basically 1 rack U of server. And that's roughly 40 racks of equipment that was deployed just to spin this up. And then we got rid of it. If we had to do that on-prem, it's basically impossible. So the Evertz team came back to us and said, S3 is too fast. We're afraid that's going to conflict with this all-important 50 megabits out, right? The 50 megabits out always needs to be going. It can't go down. So we brushed off our computer science algorithm books, and we wrote a rate limiter using the token bucket algorithm to limit how much throughput up and down out of S3. And we did multi-threaded byte range requests in order to maximize all the throughput that's available. The code to do this is up on GitHub. All of these slides are available after reInvent on SlideShare, so no need to write down that URL. It'll be available to you afterwards. Next up for S3 is we needed to replicate content across regions. So again, we're operating in a highly available environment. We're operating in Dublin and US East. We need some way to replicate the content back and forth. We could go with a partner solution like Aspera or Signiant, but Discovery is more interested in doing a fully managed solution. So we used our built-in S3 cross-region replication. Is it fast enough? So we tested single file transfers from US East to and from Dublin and got 31 megabytes per second. That's roughly 4 to 5 times real time and more than enough throughput in order to transfer these files back and forth to make our recovery objectives. Total throughput was 100 megabytes per second, so basically 800 megabits. And we did over 3,000 transfers during testing without a single failure. So this worked out as a perfectly good solution for Discovery. Next up was clustering MySQL with auto-scaling. So the Evertz team runs MySQL with Galera, which is a multi-master replication solution for MySQL. They want to migrate, a lot of customers run into this scenario. We want to migrate to AWS, and we want to leverage auto-scaling as much as possible. We want to take this sort of DevOps approach and full automation. But how do we use auto-scaling when different instances have different roles in the auto-scaling group? Specifically, we have a master node, which is the first node up in the cluster, and he's going to start the cluster up. And then we have secondary or slave nodes that come up and then now need to join the cluster. This is a very common pattern. It doesn't apply just to MySQL. RabbitMQ has the same use case. I just set up an origin for a customer using unified streaming, and it was basically the same design. When the second node of the unified streaming origin comes up, it needs to tell the primary, hey, I'm a new origin. You need to reestablish the video streams with me so that I can start distributing content to customers. So how do we do this? The first instance in the auto-scaling group starts up. He gets its instance ID from the instance metadata built into the machine itself. So that simple curl command in the lower right-hand corner can get the instance ID. He contacts the AWS API to get the instance ID from the auto-scaling group. And he promotes himself to the master because he knows he's the only node in the group. The second node comes up. He gets his instance ID from the auto-scaling group. He contacts the AWS API just as the other one did, but finds out that now he's the second node in the auto-scaling group. He gets the IP addresses of the other nodes, and then finally reaches out to the master node and says, hey, I'd like to join the cluster and start getting traffic. Another common use case that we ran into is this one, where video assets are being uploaded to an S3 bucket. So you may be uploading assets that are 10 gig, 100 gig, maybe 200 gigs in size. And you'd like to quickly get technical metadata out of that video file. So you'd like to know what the video file's aspect ratio is, bit rate, video codec, audio codec, et cetera. So how do you do this in a lightweight fashion that doesn't require you to download the full 100 gig file? So we wrote a nice blog post that walks you through this process of using media info and Lambda to do this process. So media info with embedded curl functionality will download just the ones and zeros necessary in order to extract the technical metadata and not force you to download the entire file. Next up was an issue with cross-account auditing. So this happens a lot, right? You have a third party that needs access to your AWS account. So in this case, a company like Evertz needs access to the instances that are deployed in Discovery's account so that they can manage those resources. How do you limit and audit access? How do you prevent that third party from accessing your production account and not doing any damage and not doing anything that they're not supposed to? So the simple solution is using an IAM role and cross-account IAM roles. So a user in that third-party account assumes a role in the production account, gets some temporary access keys and credentials, and then logs in with those credentials to your resources. The downside of this is to a lot of security professionals, that IAM role just looks like a shared account. It just looks like a whole bunch of people are just logging in with the same username and password. And there's no way to audit back who is the actual person with hands on keyboard that assumed the role. So we wrote this very complex workflow that solves that problem. It's available on a blog post. And basically, the end result here is in that DynamoDB table, the blue icon, information from both accounts are linked together. So you can track back to the actual user who had hands on keyboard and made those changes into your production account. And then just recently, we announced support for shared event IDs, which doesn't change this workflow, but makes the linking a little bit easier. And there's a blog post available for that. And with that, I am going to pass off to Dave Duval. There you go, Dave. Thank you.
Thanks a lot. Thanks, Michael. So we'll start out first here with just an overview of who we are. You know, we can't come here as a media company without a little brand sizzle. So we'll start off with kind of a little video about overview of Discovery's breadth and reach. We're a little bit bigger and with a few more brands than maybe you necessarily associate with Discovery. So I'll cue that up. Okay. So with that perspective on kind of who we are as a company, I'll just throw in a few stats about what that really means in terms of scale. We're at, as Michael mentioned earlier, over 400 feeds. We have offices in 85 office locations in 35 countries. We're an employee base of right around 10,000 or so employees and contractors. And the reach is truly an epic scale. You'll notice the Eurosport brand featured prominently in there. That was an acquisition we completed a couple of years back. I know for me personally, and I believe Brenton as well, you know, the notion that we're working on prepping a European Olympics platform for the first time ever, first time any rights holder's been granted pan-European rights across linear and digital. It's something we didn't think we would be doing when we went to work for Discovery Channel. I mean, we were, you know, lions and animals and nonfiction, and now we're into free-to-air, we're into sports. So it's a really interesting challenge. And so out of that, our big opportunity is how do we transition our supply chain from what it is today, which is pretty finite, on-premise predominantly, to one that is massively scalable to deal with a few opportunities. One, just the opportunities of what our acquisitions bring us, what these new business models bring to the party here, but also just the very real threat of disruption that all media companies are facing right now. I mean, if your business is a linear pay television-based platform, you've got some problems to solve going into the future, right? I mean, you really need to make that leap and jump the knife across to OTT, across to direct consumer engagement. We've been in a B2B model for the life of Discovery. We sell company to company. Now we need to engage with all of you, to engage around our content. So how do we do that with speed to market, increase the quality, contain the costs? How do you solve for all those things? Little picture of our scale, 6 major data centers within that that we consider major class. Sterling, Virginia, Silver Spring, Maryland is kind of where the company grew up. That's where most of our US and Latin American nets originate from. Miami's Latin America headquarters. London handles most of the European operation. Paris is where Eurosport is based, and then Singapore covers the Asia Pacific business. So why cloud, why now, why all these things? It's a little bit of what I said. It's the external threats, it's the inevitable and continuing maturation of just IT technology. This is the next hill to climb. We went from physical servers to VMs. We increased density. Now I need to go tap into scale, and now I need to get out of the business of rack and stack and all the things that come with that. Information security is a big angle. We're definitely within Discovery believers in that a specialist, someone who is focused on full-time, that is the company mission, securing, running data centers, running infrastructure platforms, will do a better job inevitably than a company whose core mission is media and content. And certainly we've got great engineers within our IT organization, don't get me wrong, but there's a certain limit to what we can invest as essentially an overhead function of the company. So, the ability to tap into infrastructure done well, infrastructure done right all the time at a scale that's pretty limitless is certainly attractive and a big component. So our evaluation process when we decided how do we go into cloud, there were several things that drove our interest. One was very real, real world physical problems. We have a couple of those data centers in leased buildings. We don't own all of those facilities. So you're inevitably dealing with real estate issues, timing, do we get out, do we move, weighing those costs. That was certainly a big driver, as well as just scale and efficiency. So when we decided to start the process, we did a few things. One, we engaged with the Amazon team, AWS PS. We worked on architecture workshops, really dove into what it means culturally within the team. How do we embrace sort of DevOps mindset and perhaps team structures and get to a more agile deployment methodology. The way we approach that, we formed what we called internally the Cloud Tiger team. By the way, if you type Cloud Tiger into Google Image, that's what comes up. And so that was the unofficial logo of the team for a little while there when we started getting our arms around how do we do this, what's different, how is this different from running a VM, what am I in for here, both from an infrastructure team perspective as well as development organization. We also started looking at our media vendors. We knew that the facilities that were challenged with the leases expiring and the tech refresh we were inevitably facing, we knew there were some vendors in our industry that are not ready to come along on this journey with us. We had to really start going out, talking to our partners, finding the ones that were willing to jump from hardware-based solutions on premise to one that's a little more software-based and cloud-friendly as we progress along this journey here. So once we got that done, or once we got that started, we're still not done. Don't think we'll ever be done. We moved on to sort of foundational design elements. So we're very focused on just get the core right. We very much looked at this as we're building greenfield data center. You don't get to do that very often. So we very much looked at cloud as we're going to undo all those things and sins of the past that we didn't get right the first time around. Get rid of a lot of the bubble gum, the baling wire, the things that are just sort of keeping the operation together, and build one that's from the ground up, a little more automated, a little more scaled, a little more with some insight into how we want to build it. So a lot of focus on monitoring, hooks back to CMDB for ITIL and change management processes. Just soup to nuts, how do we do this? CI/CD is great in concept, but we still have a SOX audit that we have to pass, and we still have controls and access controls, and so it's slowed it down, but it was definitely one that You're paying the tax up front. Once you get it right, we do feel like we've got a scalable process now to let that grow. So we did 2, or really 3 things in that first, say, 6-month window there. We did a cloud native app build. So we started work on supply chain, kind of media ingestion from our content production partners. Britton's going to talk about that a little later in his deck. It's very much a microservice-based, cloud native, it's fresh build. It was something we could really tap into what it feels like to build on AWS and have it take advantage of everything the platform has to offer. And then we also took a stab at a hybrid model. So we picked some representative applications that fit some patterns that we thought we would encounter quite a lot, did a hybrid build. The one we picked ended up being, like moving all the storage for, say, a asset proxy library out to S3, but keep the app on premise and see how that works and see what problems and challenges we have to solve. A lot of firewall challenges, in case you were wondering. So you're sort of picking apart that, how do I now build and extend my data center out to AWS? Hybrid app, and then, of course, lift and shift was kind of a last step, just literally taking a VM workload, essentially changing the IP address and rehosting it out on cloud. How do I accomplish that? What sorts of tools are out there, partners, et cetera, to help us do that sort of a shift? And then finally, once you've done all that work and you've sort of proven to yourself this is viable, now you proceed to the harder part, and the part that generally engineers don't love doing. Financial analysis for one, picking at that TCO calculation. How do we justify that this is the right move for the company? Now, in our case, and this would be something that we've learned, is when it comes to sort of an all-in analysis, you truly have to make it an all-in analysis. You have to be bold enough to point your financial calculator and your model at an entire facility envelope. If you leave anything on the table, if you tell yourself, well, if I move 2/3 of these workloads out of this data center, then there will be some inherent efficiencies. No CFO on the planet is going to give you any credit for, some potential percentage power savings because you made a building 2/3 less full. In fact, if anything, you've just taken your efficiency of that building to the floor. You're in a bad position. So we really had the luxury of looking at a whole building envelope. Once you do that, you can really account for a lot of non-technology costs that go into operating a data center. Things like guards have to be there 24/7. Reception has to be there during business hours. You've got a lot of just overhead of running a technical facility. Even if it's kind of a relatively lights out building, there's still an overhead to doing that. So once you account for all of those things, from a cash perspective, and that's very important when if you're in that position of having to address your CFO, to really be focused on cash flow, both sides of the budget, the capital budget as well as the operating budget, and can you make that case that from a cash perspective and a sustaining perspective, this is the smart thing to do. And certainly for us, that's what we looked at. Linear television, we think on the whole, has some sort of shelf life, right? I mean, it'll be around a long time, but will it be at the scale? Will it be the predominant medium that it is now? We think for quite a while, yes. But this is the point we're at. We have to make this a massively efficient process now. We also worked on Migration Factory. How do we scale lift and shift so that I can empty a building? If I have a lease that expires in a year and a half, how do I move all those workloads out? We went and interviewed a few partners, got a feel for the marketplace, ultimately selected CloudReach to help us with a Migration Factory approach. That's being done with a lot of replication. So it's VM replication. It's very simple, true lift and shift. In our case, we decided it was in our interest to move out to public cloud quickly and refactor in place on the public cloud, reassess TCO on the cloud. Ultimately, we may move some workloads back, we may refactor some applications, but we wanted to get the team focused on moving fast. And a lot of that did have to do with the building timing. And finally, monitoring and compliance. So now how do we scale things like audit and detection events? Some of the things we learned in the foundational design, now it's proved that out. So now it's making sure we've got good data flows back and forth to on-prem systems that run a lot of our controls and release processes. So our view of the world, this is really a perspective kind of pretty current to now, kind of when we started the project. Media technology space, incoming content, tech evaluation, storage, all green, all good. Cloud can handle, a lot of what we want to do in that space. Post-production, kind of yellow light, maybe. there's still some limitations of an editor sitting down and being able to edit really rich content across a latent hop like that. Transcode and playout, we think it's ready. We're going to talk about that later in this deck. The act of the video server spitting out a 50 megabit stream to ultimately go to air, very good and very ready. Delivery, encoding, and linear delivery, when we talk about that, we're literally talking about the act of putting it on a satellite and distributing to an affiliate. So that obviously still, from a physicality perspective and certainly from a point to multi-point distribution perspective, nobody's solved for that quite yet. We think encoding is quite close. Linear delivery is a big challenge. I'll talk about that a little later in my deck. Corporate IT, really everything's kind of ready. The only reason we put ad sales red is because of, in our industry, the particular vendors we deal with, not very friendly to cloud transition. It's not that somebody couldn't build an ad sales system that could be cloud friendly or could be cloud hosted. It's just the ones we have, for us, not ready today. But nearly everything else predominantly is. Finance and HR, in our case, that's really very discovery specific of why that's yellow. That's more to do with our architecture and just some risk evaluation on the ERP side. So what are we doing first? Corporate IT is going to focus on, because of the facilities we have that are driving a lot of our move, we're going to move 80% of our workloads from about, starting line was maybe 3 months ago to the end of 2017. So we're projecting to move about 1,400 workloads over that period. It's going to be quite a lot of work, but again, it will be a lot of lift and shift. This will be leveraging that Cloud Reach migration factory approach to get that done. Content pipeline, that ingestion or that receipt of assets from our production partners, very similar to what Michael and Turner described in the last session. We have a very similar system using a lot of the same partners that they use. That's already there. That's live. We're ingesting with that, and that process is proving itself out. Linear playout starts moving now, so we've got 150 channels teed up over the next 12 months that will move to playout from AWS with our partner Evertz. And Brinton will go into detail in his section on that. Post, soon. There's definitely some aspects of post that we think are ready. Certainly some lower end editing needs can be done with remote display type solutions to get that done. And then B2B distribution. This one's hard. The vendors are not very motivated to change. Obviously, if you launched a satellite 10 years ago and it's going to be in space for 10 more years, you're not too keen to sort of move off of that. You've got to, fund that asset for its life. So those will be interesting, but we're looking to peers or to companies like Equinix and others for doing more point-to-point distribution, peering facilities, things of the like to solve the network distribution challenge. So I'll dive a little deep into what we did to design a network that can support playout. These are sort of operational needs and risks that we have to account for. You got to account for a lot of bandwidth and interconnection to pull this off. Timing and latency issues. It may have slipped past your notice, but our primary region that we play out of, say, a US network will be US East. The B side, the backup feed, will be playing live 24/7 from Dublin, from EU West, and we'll be bringing it back transatlantic. So right out of the gate, you've got 70 milliseconds, 80 milliseconds of latency you have to account for between your primary and your backup to bring them back into sync to be able to do a smooth cut if you have a problem on either side. So there's very interesting stuff there. Then resiliency, redundancy, and of course security and inspection. This drawing up here represents, we have two major playout facilities, one in the UK, one in the US. That's the bottom two boxes there. And then the 4 boxes in the middle are the 4 co-location facilities that are direct connect sites. So it's 3 Equinix facilities and a CoreSite facility, 2 in Europe and 2 East Coast US. So how do we do this? Well, first, redundant direct connect sites. You don't want to be in a position of having a single direct connect failure bring down your private access to there. So it's very important that you're building redundancy, especially if it's attached to as significant a revenue stream as ours happens to be. Playout traverses out of public cloud down through these co-location facilities and onto our on-premise facility. As far as timing and latency of how to go back and forth, PTP has been a big part of playout timing. Clock is very important in synchronizing frames and making sure that when you cut and you have to do a cut from an A to a B side, feed that you've got that and you're not dropping frames in that process. So with cloud, that gets very interesting. PTP is multicast based, and AWS, there is no multicast today. So what we've done is our partner Evertz has done a work on master PCR. So we're doing the clock is in the stream essentially, much like it would be in an MPEG transport. And so that way we've got a good synchronization record to make sure that those frames can get realigned when they get to the other side. So that's kind of the glue that's making sure that we've got a cloud-friendly way that doesn't have an inherent need for a network protocol to be functional, a multicast-based protocol to be functional to solve for that latency challenge. Now, resiliency, redundancy, and security, kind of all in one. I really zoomed in to say our UK colo design. What we've done here is we solved for a couple things that are quite interesting. One is the kind of jar of Skittles there that you see that's a logical segmentation of a physical router. So those are Juniper MX480 platform routers that we've applied 6 VRFs to that router. So what we're doing is we're basically segmenting video playout traffic, the real-time traffic, from general purpose, say, command and control traffic, IT traffic, things of that nature. What we've been able to do is, through a lot of conversations with our CISO and our InfoSec team, get some blessing around a statically defined stack of dedicated VRF, instances secured with security groups on the AWS platform, and stitching together that very kind of relatively static path. There's still plenty of dynamic routing within there to solve for failure scenarios, but as far as the path, the most important thing is we're not traversing that video playout through a firewall. We're not passing it through some kind of layer 7 inspection for that sustained stream. We wanted to make sure we were having relatively untouched traffic in there. And we were able to, we think, come to a really good design that secures that traffic, that locks it down to a very discrete origin and destination and preserve the security. Now we have service-based policies that if we see unidentified traffic, it will divert into that route or into that firewall platform through those other VRFs and be able to have inspection that's kind of fluid and reacts to changing traffic or unexpected traffic and still not have the thing just sort of melt down around our feet. I think, this part of the design is one that I'm particularly, I think we've done something really nice here because firewall costs for this sort of a scenario would be quite significant. I mean, we're at, across the whole solution, 120 gigabits of provisioned direct connect capacity to do the full scale solution. So you can imagine the firewall costs on that are quickly get into the millions of dollars very quickly. So with that, I'm going to turn it over to Brinton to cover the last pieces here, which is talking about content ingestion and then the playout. So turn it over to you, Brinton.
Thank you. I'm going to talk a little bit about sort of how we thought about moving media workflows to AWS. Playout really was the goal that started us down this path, but we realized pretty early on that in order to get to playout, I need something to play out. So, we have hundreds of petabytes of video content in our library at this point. How do we start getting that content up there so that we can start exploiting that content either for linear playout, for nonlinear content distribution, and other sort of manipulation processes that we do day in and day out at Discovery. So the first project that we took on, and Dave mentioned it in his bit, was our content supply chain project, which we affectionately called OnRamp at Discovery. It's a sort of modern stack, microservices-based, web-scale sort of centric media delivery and processing environment. We do QC there, we do file delivery, we do lots of transcode there, we do sort of a lot of the fundamental sort of media processing jobs. This is an interesting slide. This is where we were way back in 2012. So content comes to us, lots and lots of content comes to us, as you can imagine, with 420 networks around the globe. Most of the time it's been coming to us in the last couple of years as files, not always. But it's been a very linear process. Making linear television, unfortunately, has been a very linear process for for the history of television. Lots of people touch an asset, lots of systems are required, and traditionally we've had to build to our ceiling. So at any given moment, we may only be utilizing our traditional on-premise infrastructure 20, 30%. But we had to build on-prem infrastructure to accommodate for the surges. So very much like the Turner conversation before this one, very similar challenges. So what we sort of envisioned was a cloud-based, scalable content factory that takes content in and based on upstream business systems have a myriad of data-driven workflows to deal with fulfillment of linear, fulfillment of nonlinear, making all the things for iTunes and Digo and our own internal OTT products. And that was really the idea behind sort of this first on-ramp project. And again, with receiving all of our content in the cloud, it starts building up this repository. So I can run this thing for 2 years, and my 2 years of most recent content is there. I'm probably in a pretty good place to start Cloud Playout because I don't have one of everything necessarily yet, but I probably have most of the stuff that people are watching right now. So what we built was sort of a combination of things. So we built upon an internally grown inventory and media asset management / workflow system called Discovery Hive. That's an old homegrown sort of Java application or series of applications. And we layered it on top of SDVI. I think Turner also mentioned SDVI is our sort of resource management partner for all things in this content supply chain world. We've also heavily utilized SNS as to integrate to all of our sort of legacy applications. We've tried to sort of embrace messaging buses in this move to cloud. From a processing standpoint, we've got transcode, we've got file-based QC, we've got a couple different types of file-based QC, we've got antivirus, we've got a bunch of services that we're running to handle all these different video workflows. We're adding services probably every 3 weeks, 4 weeks right now. From a file movement standpoint and file acceleration standpoint, Signient Flight is a sort of file acceleration product. Most of the video files for us are in the 100, 120 gig range for a 1-hour program. And then we're storing on S3 and Glacier. We're doing it in multi-regions. We're auto-replicating around the globe. And the system is designed to basically work in this hybrid world today. So I still have a lot of on-premise infrastructure, doing a lot of video processing on-premise. So based on what's the show, what network is it going to go on, and what part of the world is going to dictate whether or not it's driving workflow in the cloud or if it's passing it down to on-premise infrastructure while we sort of continue to push everything to cloud. So linear playout. So this was the big one. So Michael took us through sort of a lot of the detail in the tech, but I want to touch a little bit around sort of how we thought about what linear playout needs to look and feel like in the cloud. This was our legacy problem. This is an eye chart, don't try to read it, but every device shown here is a box, probably with a video wire going in and out of it, and each one has its own custom use or custom function. Everyone is probably built by a traditional broadcast manufacturer, and it's very much black box appliances. Some of that may be sort of x86 compute, but probably not. And this has been broadcast for my entire time in television. And while people are starting to pick away at doing more stuff in software on-prem, there was, it took a bit of pushing to get, the industry starting to think about how could this look and feel in public cloud. This is a little bit of a review. I think we've talked about this, but our motivation was, we had a lot of infrastructure in a lot of data centers that we built at the same time, and they were all hitting a refresh cycle right at the same time. And while we probably could do one more generation of on-premise sort of video playout build, we really decided that between the pressures on the industry, between new needs, as we launch new products, there's needs to launch sort of video streams much faster than we ever needed to before. In order to build that for every single channel, takes months and months and months of effort between just getting that many things to deliver on your loading dock and then rack and stack it and build it and train a staff on how to use it. It took a very long time. So we needed to move into a world where we're a little bit more agile. The good example, what would we need to do if we needed to stand up 6 networks during the Olympics for just additional Olympics coverage and do it for 2.5 weeks, and then that workload would go away? In the traditional model, we would spend millions and millions of dollars in infrastructure, and we would stand it up, and we would play video out of it for 2.5 weeks, and then we'd turn it off. We may not even turn it off. We might just let it burn. And it just is inherently inefficient. And again, I mentioned, the digital landscape is changing faster than, the industry can keep up with. There's always new products, there's always new ideas, there's always the next Snapchat or whatever coming about that wants video, that needs video, and we need to be able to deliver that video as quickly as possible. Media vendors. So a lot of these companies that make black box appliances for the traditional broadcast sort of master control environment either may not be motivated to change because they sell boxes, may not have the ability to change because they've got years and years and years of capital investment in their own products, and are sort of shooting themselves in the foot a little bit if they pivot to a new product. They may not have the capital to invest in retooling their product stack. So it was a challenge. We talked to a lot of folks that said, we're not interested in working with you on public cloud. We might be willing to put something in a VM for you on premise. And that just didn't solve our needs. Industry challenges. So there's a lot of black box appliances in our world that are requirements of the industry. So viewership measurement is a good example of that, where it's not necessarily in our control that, hey, I want to take a product and make it software and run it in the cloud. It's not necessarily our call. We have to wait for a lot of the industry to sort of say, okay, we're ready, we're going to do this. Economics, Dave mentioned, we spend a lot of time building the financial model for this. I've lost probably a year of my life to building financial models. The move from CapEx to OpEx is an interesting one, particularly if you're in a publicly traded company, because CapEx is, quote unquote, below the line, and OpEx is, what you want to save. You don't necessarily want to spend more. So as you go to cloud, as you go to consumption services, whether that's infrastructure as a service or more software as a service, that's driving up your OpEx. And what we figured out, in the first couple months of chomping on the numbers was that for us, the right answer was an all-in story. So it's looking across IT, looking across the media organization, and sort of saying, okay, if we move everything, what does that get us? And the answer is we ended up with a really good story. I mean, the cash story is great, spending, way less CapEx than you've ever spent before on stuff. I'm no longer buying things with blinky lights and power cords. I am spending OpEx, but if you look at all the power and all the rent and all the, people and diesel fuel for generators and, maintenance contracts for UPS batteries and, FedEx charges between different Discovery facilities. If you have the financial sort of will to sort of left no stone unturned, you can find all this stuff, and if you can recover it, you've got a good financial story. And so we're very much in a mode where, during this transition period, we sort of call it getting fat to get skinny. There'll be a surge, but we'll level out, and we'll level out in a very good place. And then public cloud architectural challenges. That's really what Michael was talking about at the beginning of this presentation. All the things that we had to test in order to give us the warm and fuzzy feeling that the platform could handle it. And we had great results on all the tests. And the last one's basically change management. I think the Turner guys said the same thing. TV people change slowly. I mean, everyone changes slowly. That's human nature. But TV people have been doing it the right way, they think, since the 50s. And why change? If it's not broke, don't fix it. So getting our technical teams retooled took a lot of effort. Getting the operations teams on board with different and new process. They may, because we're trying to minimize egress, when you're QCing a video file, you might be looking at a proxy, and traditionally we wouldn't do that because you want to look at the thing that's going to be on TV. You don't want to look at a representation of it. So just the change management has been a constant challenge in this sort of last year and a half of project work. So what are we doing? Each of those is, in essence, a function in a linear air chain. So that first scary drawing, each of the, this is sort of a high-level representation of what that is. So the goal was picking that stuff up and moving it to software. You notice that the traditional satellite distribution bit is staying in heavy metal hardware. That's the next thing to pick at. A lot of companies in our space had already been picking at this. So there's this concept of a channel in a box in television. So a lot of these were already there, not all of them. So we had to work with Evertz, our partner, to sort of complete the stack. But that really wasn't where the hardest parts of this were. So convert everything to software, move it to the cloud, easy enough. I think this is sort of our model. Dave mentioned it earlier. We built this massive network to sort of say, all right, we want to embrace web scale technology or web scale approaches, but television's a little hard just because of the sheer size of the video files and the bit rate of the outputs. The instances we need to use for this are the biggest and baddest instances on EC2. So I don't want to run 50 discovery channels. I'd love to be able to run 50 discovery channels, but we just wouldn't be able to make the economic model work. But we needed as much redundancy as possible. So we needed to come up with an approach where we can split channels across AZs, split across multiple regions to ensure redundancy. So this is really sort of the interesting bit in my mind. A lot of the work hasn't been around how do you play out video from the cloud. That's relatively easy. A lot of it's been around how do we respond to issues when it's, traditionally it's been people in a room seeing a problem with video and hitting a button to switch video. Now it needs to be data driven. Now it needs to be monitoring CloudWatch for reduced capacity within a region or an AZ and making an adjustment. So if we had an AZ where we're running 2 channels, we need to be able to meter that and react to that. So we have a whole monitoring stack that's going to gesture a video switch while we react. So we stay on air, the home viewer doesn't know isn't the wiser, and we have time to deploy additional instances in a different AZ that's not having a problem. Similarly, if we had a complete region outage, we would be doing the same thing, where we'd be able to, based on an SLA, spin up additional channels in another region, given it enough time and transfer time for inter-region transfers for the video content. I'm sorry, I'm a couple of slides behind. All right, there we go. So monitoring. So that's what's driving this whole thing. Our traditional world in broadcast television has been sort of the media stuff and the IT stuff, and we've really had to bring it together. We've got monitoring tools sort of out of both disciplines between SolarWinds and CloudWatch and Splunk. DivvyCloud is something new that we've sort of jumped into recently to monitor our cloud environment. We've got VistaLink and Insight, which are monitoring tools that Evertz provides for us monitoring sort of a lot of the video side of this. And we needed to aggregate all this alarming and all this monitoring data, present it to users in master control pods, present it to engineers and developers in the form of tickets in ServiceNow. And we needed to be able to feed back into our systems to react when we need a system to react faster than a human would be able to. So the previous slides, sort of that reaction is really the amalgamation of sort of all these different monitoring environments all coming together and gesturing changes in the infrastructure. So what's next? This is just our European distribution footprint. We want to start moving to sort of IP-based distribution, sort of B2B distribution. There's certain places in the world where satellite is very much a thing and will be a thing for many years to come because there's thousands and thousands and thousands of cable companies in India, for example. But the United States, Western Europe, all seem like sort of areas where we could sort of pick at colo solutions or other mechanisms for distribution. As we get into early next year, we're starting to test multiplexing as a service. We're working with a couple of partners on that. The goal there is really minimizing as much as possible our egress out of cloud. So we're saturating 120 gigs of direct connect for our first 150 channels. That's not even the full 420. How do we, start picking away at that? How do we drive those numbers down? There's a challenge here still where the MVPDs, the cable companies, have to get on board with receiving signals in a different way. That's, sort of not my problem, luckily, but it is something we'll have to pick at. Encryption, that's really, can we start, if we can move to sort of point-to-point distribution of our video content, can we move away from custom encryption tools that we use on satellite? So we do a lot of encryption of our video signals so that people can't intercept the signal that's coming down off a satellite because everybody that can point a dish at the sky can technically see that. Can we move to sort of web standard encryption technologies if we can move to a point-to-point or a come-meet-me type solution where the MVPs are just picking our signal up either directly from AWS or through a peering facility. And with that, I think that's the end.
Do the next couple.
Thank you, guys. I don't think we have time for questions, but I want to thank you guys again very much. That was a wonderful follow-on. I think a great walk through a very complex workflow. So folks, we have one more session coming up, which is really good. We're going to walk through some high-end content production tools and video effects. What we do need to do is clear the room. We'll start back up at 5 o'clock. So if you guys can go back out through and come back and check in, we'll see you back here at 5. Thanks.